Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon to all of you. So today we will continue our dynamics class, okay, with the third subchapter. We have covered previously two topics. The first topic is the introduction to kinematics. Okay, I have explained that kinematics is basically the characteristic of the motion. So kita berbincang tentang position, displacement, velocity and also the acceleration. And then in the second class, second lesson, we talked about constant acceleration, the case where the acceleration is constant. So acceleration objek tersebut sentiasa tetap ataupun tidak berubah, value-nya tidak berubah. So in the case of constant acceleration, we can derive three new equation based on the basic kinematic equations that we have. So for today's class, we are going to discuss about erratic motion. So previously, if you recall, I have been explaining about continuous motion. So now we will discuss erratic motion. So apa beza dia? I will explain later. Okay. So now let's look at what is the outcomes for today's lesson. So today, after having this lecture, you should be able to understand rectilinear erratic motion with piecewise function and motion graph. Okay. And then the second outcome of today's lesson is for you to be able to solve problems related to rectilinear erratic motion. Okay. Let me explain what is the difference between continuous and erratic motion. So in the previous lecture, we talked about continuous motion. Continuous motion ni maksud dia throughout the motion. Katalah objek tu bergerak from point A to point B. The equation for velocity ataupun acceleration is explained by one equation sahaja. Contohnya A is equal to 2t square plus 4, for example. So throughout the motion, equation dia sama sahaja. From point A to point B, from time equal to 0 to time equal to 10 seconds, for example, sama. Dia punya pergerakan tu sama, continuous. Dia kekal bergerak dengan keadaan yang sama. So the difference with erratic motion is, okay, later we go to that basic kinematic equation. The difference with erratic motion is the opposite kepada continuous motion tadi lah. So in erratic motion, position, velocity, acceleration cannot be described by a single continuous mathematical function. Maksudnya, dia tak boleh ada satu je mathematical equation untuk describe motion dia sebab dia berubah-ubah. Okay. So erratic motion ni basically kita boleh define sebagai pergerakan yang berubah-ubah. Contoh yang sebenarnya kita dah buat satu contoh in the previous class. You remember the train. Train tu bergerak dari station A ke station B. Kan kita ada 3 phases kan, 3 fasa of the motion of the train. So train tu bergerak mula-mula dengan, if I'm not mistaken, with an acceleration, and then dia ada constant velocity, for example, acceleration equals to 0, and then dia decelerate, dia brake, decelerate, and then dia stop di station B. So basically ini ialah satu contoh erratic motion lah, di mana pergerakan tu daripada satu point ke point yang lain tu tidak sama, bukan dalam motion yang sama sahaja daripada A ke B, tapi dia ada perubahan. So this is what is known as erratic motion. Okay, boleh faham? Ada siapa-siapa yang confused tentang erratic motion? Ada perlu saya explain sekali lagi kalau ada yang confused? What is the meaning of erratic motion? So dia basically lawan dia ialah continuous motion lah, yang kita belajar sebelum ni. Continuous, sama sahaja pergerakan dia, sifat pergerakan tu ataupun characteristic of the motion tu semua sama sahaja from A to B. But in erratic motion, the character is different. Okay. So cannot be described by a single continuous mathematical function. A series of functions ataupun in mathematics it is called piecewise function. Apa piecewise function tu? Macam yang ada dalam biru ni lah. So A to represent A, the acceleration, it has to have 3 equations untuk different timing. Ni nama dia piecewise function. Okay, you tengok from t equals to 0 until 10 seconds. A is equal to 0.4t. And then from t equals to 10 until 20 seconds, A is equal to 2.4. And then from 20 seconds to 30 seconds, A is equal to 0. Okay, so this is what we call as erratic motion. Maksudnya, dia punya karakter tu berubah-ubah mengikut masa. Sometimes it can be with respect to time, sometimes it can be with respect to the displacement pun boleh. Okay, so a series of function ataupun piecewise function will be required to specify the motion at different intervals. So different timing ataupun different displacement position, equation tu berubah-ubah. Okay, and it is convenient to represent the motion as a graph. Okay, so macam mana kita nak selesaikan this chapter ataupun subtopic is by going back to the basic kinematics equation. So kita masih lagi pakai V equals to ds over dt, ataupun the velocity is the change of displacement is divided by the change of time. A, the acceleration, is equal to dv over dt ataupun change of velocity divided by change of time. Then by rearranging these two equations, we will have the third basic kinematic equation, which is A ds is equal to V dv. Okay, so kita akan menggunakan tiga equation ini untuk solvekan problem in this particular subtopic. Okay, ada apa-apa yang tak faham tentang erratic motion? Ada yang keliru? Apa yang saya explain tadi? Semua boleh? Boleh faham? Okay. So kalau boleh faham, let's continue. Okay, now kita ambil daripada equation yang saya tunjuk tadi. Okay, now let's bring this equation to the next page. Okay, now saya bagi tahu yang this is called a piecewise function. Maksud dia, the acceleration is represented by 3 different equations based on dia punya time interval. So 0 to 10 seconds, A equals to 0.4t. 10 to 20 seconds, A equals to 2.4. 20 to 30 seconds, A equals to 0. Okay, macam mana kita nak lukis graph? Okay, basically this subtopic is for you to be able to draw the graph of the motion. So kita akan lukis graph acceleration lawan time, kita akan lukis graph velocity lawan time, kita akan lukis graph displacement lawan time. Okay, so these are 3 parameters ataupun characteristic of the motion. Dan satu lagi example saya akan tunjuk in this class will be to draw the acceleration versus displacement graph, A lawan S, dan juga velocity lawan displacement ataupun Vs graph. Okay, so let's draw the the graph lah. Okay, so acceleration is in y-axis. Okay, y-axis dia ada acceleration. X-axis ialah time, t. Okay, so siapa boleh bagi tahu saya for the first case ataupun fasa yang pertama, t equals to 0 until 10 ni, 0 until 10, what will be 0 until 10, what will be the graph? Macam mana graph tu looks like? How does the graph looks like? A equals to 0.4t. Macam mana?
Linear.
Linear, okay. So macam mana bentuk graph dia?
Straight line.
Straight line, great. Okay, so straight line dari mana ke mana? Okay, this is where you need to use the equation. Okay, for example, you want to know dekat mana the point to start. So from 0, at t equals to 0, you key in 0 in the equation. So you will get 0. So it will start at 0. When t equals to 10, what will be the value? So you key in the value 10 in t here in the equation. So you will get 4. So basically, at t equals to 10, the acceleration a equals to 4. At t equals to 0, the acceleration is also 0. So you will have a straight line, linear graph like this. Okay, this is for the first phase. Okay, fasa yang pertama. Okay, selesai, settle. Let's go to the second phase. T equals to 10 until 20 seconds. So what will be the graph for this time? Anyone?
Straight line.
Straight line, okay, di mana? Straight line di mana?
2.4.
A sama dengan 2.4.
Okay, good. A sama dengan 2.4. This is the equation. A equals to 2.4 from 10 until 20. So you will have a straight line at 2.4 lah. See, this is approximately 2.4 lah saya punya garisan ni, okay? So you will have a straight line from 10 to 20. So you can draw a connecting line lah between the first phase to the second phase. Okay, what about the last phase? 20 to 30 seconds. Here A is equals to 0, so obviously you will have a straight line down here. Okay, 20 to 30, 0, no acceleration. Okay, 0, or which means that the velocity is constant lah. The velocity is constant at this moment, at this phase, so the acceleration is equal to 0. So you can draw another connecting line. Okay, then this part is settled for acceleration time graph. Ada apa-apa soalan? Do you have any question on drawing the acceleration time graph? Ada yang tak clear? Ada yang tak clear boleh tanya. Kalau tak, saya akan proceed ke next. Tak ada soalan, eh? Okay. If you have any question, you can always interrupt and then you can ask straight away. Okay. Now, let's go to the velocity time graph. Okay, tadi kita dah draw acceleration lawan time. Now, we would like to draw velocity versus time graph. So, how do you draw this? Okay, now we go back to the equation yang kita ada sebelum ni lah, which is the basic kinematic equation. We know that A is equal to dv over dt. Okay, di sini is how we can get the velocity punya equation so that later we can use the equation to draw the graph. Okay, so based on this relationship, A equals to dv over dt, let's look at the first phase. T equals to 0 until T equals to 10 seconds. We can rearrange, okay, kita boleh bawa dt ni naik ke kiri so that you will have dv equals to a dt. And to get the value of velocity, you will then integrate both sides lah. You integrate dv, you akan dapat v. When you integrate left side, you have to integrate right hand side also. So you have to integrate a dt. Okay. Now, A, kita tahu A is equal to 0.4t for this phase. So you will substitute 0.4t in A here. And then the integration must have a limit lah from berapa until berapa you want to integrate. So basically, Now kita start daripada 0. So you know at time t equals to 0, velocity dia 0. So you put in 0 kat sini lah, because this must be starting from rest, daripada something yang tidak bergerak and then it starts to move. So pada time t equals to 0, velocity must be 0. You integrate until v, because kita the upper limit mesti kita punya parameter lah v. Okay, that is for the left side. Okay, ini 0 to v for dv. On the right hand side, kita integrate now dt lawan masa. So you will start from the lowest limit of the masa, which is t equals to 0. So dekat sini t equals to 0, and until you tak perlu letak 10, tapi you kena letak t, because kita nak tahu masa tu bukan daripada 0 to 10 saja. Kita nak tahu 0, 1, 2, 3 until 10. So you put in 0 until t. Okay, for the integration of dt. Okay, now what you will get is on the left hand side is v minus 0. Betul lah? You integrate dv, you will get v. And then you substitute the lower and upper limit, it will be v minus 0 lah. The upper limit is v, lower limit is 0. So v minus 0. What about this one? On the right hand side. Ada siapa-siapa boleh bantu saya, tolong bagi jawapan. What is the equation ataupun formula yang you dapat on the right hand side after you integrate this?
0.2 t square.
0.2 t square. Betul? Okay. It's basically 0.4 t square bahagi 2 lah kan? Betul lah? So you will get 0.2 t square. And then integration ini daripada lower limit is 0, upper limit dia t. So when you substitute t, you akan dapat yang ni. When you substitute 0, you akan dapat 0. So dia kekal dengan inilah. Dia kekal dengan 0.4 t square, ataupun when you divided this two, 0.4 dan 2, you will get v equals to 0.2 t square. Ini equation untuk v pada fasa yang pertama, which is t from 0 until t equals to 10 seconds. Okay, now let's draw this part. Macam mana kita nak draw graf untuk ni 0.2 t square? Siapa tahu graf t square ni macam mana? Quadratic. Okay. Kalau ada yang tak tahu, saya nak tunjuk dekat you. Saya pun baru je discover benda ni. You can actually go to Google, and then katalah you tak tahu kan, you nak, bila kita nak draw graf ni, kita nak tahu macam mana rupa dia lebih kurang graf ni. So you ada dekat sini v equals to 0.2 t square. Okay, jangan letak v dan t, you kena letak y dan x. So you just type in y is equal to 0.2 t to the power of 2. Okay, macam ni y is equal to 0.2 t to the power of 2. When you enter, Google akan generate rupa graf ni pada you. So you boleh zoom in atau zoom out, dan you boleh klik dan gerakkan dia. So basically yang kita interested ialah from 0 dekat sini until 10. Mana 10? Okay, 10 lebih kurang somewhere dekat sinilah. Okay. So this is how the graph should look like lah. Dia macam, dia curvy, dia curve graph. Okay. So you get the idea macam mana rupa graph ni 0.2 t square. This is how it looks like. Okay. So now let's go back to our graph. Okay. Now kita ada 2 point, 0 dan 10 seconds. So kita nak tahu bila 0 berapa value of v. So sekarang kita ada v on the y axis, kita ada t pada x axis. Sama macam tadi. Pada y axis ialah acceleration a, pada x axis is time lah, t. Okay. So pada masa t equals to 0, you substitute t equals to 0 dalam ni, you akan dapat v equals to 0 also. So dia starting point dia 0, 0, 0. Now kita nak tahu pada t equals to 10, dia jadi berapa? So t square, 10 square is 100, multiply with 0.2. So you akan dapat 20. So okay, pada 10 value V ialah 20. Okay, value V ialah 20 pada time t equals to 10. And then you tahu from tadi, you tahu yang dia ialah a curve punya graph. So you can straight away draw a curve, ataupun kalau you nak make sure, you can get the value for middle point pula. Let's say 5 here. So you key in 5 in here. 5 square is 25. Times 0.2, you akan dapat 5. So pada time t equals to 5, velocity is equal to 5 also. Okay, so t equals to 5, v equals to 5, t equals to 10, v equals to 20. So now you get 3 point daripada 0, 0, 5, 5 and 10, 20. Now you can draw the curve lah. Okay, you can draw the curve. So this will be the curve for the first part of the velocity time graph. Ada soalan? Until now, until this part, do you have any question?
No, sir, clear.
Clear, good. Okay. Kalau siapa-siapa ada question, just boleh type di chat box kalau you segan nak tanya, or you can turn on your microphone and tanyalah. Okay. Now, let's move on to the second phase. Okay. Now, T daripada 10 saat ke 20 saat. T equals to 10 seconds until 20 seconds. Sama juga, kita masih gunakan this equation. Kita masih gunakan integration of dv equals to integration of a dt. Datangnya daripada this basic kinematic equation. Okay. Now, di sini saya nak minta you hati-hati sikit. Can I zoom this? Okay, I would like to zoom in here. Okay, di sini kalau you tengok dv ni bermula dari 20. Lower limit dia 20. Mana datang 20 ni? 20 ni datang daripada sini. Nampak? Kita dah calculate at time t equals to 10. Nampak? Sekarang kita punya phase kita ialah daripada 10 until 20. So we need to know what is the velocity pada lower limit fasa ini for this phase, which is 10 seconds. At 10 seconds, t is equal to 20. Kita dah calculate di sini lah. Kita dah calculate di sini using this equation. Using this equation yang kita dapatkan before from the previous phase, and we get at time t equals to 10 seconds, v is 20. So dekat sini you must put in 20, bukan 0. Bukan 0. The integration here is from 20 until v. Okay, dv. On the right hand side, is the integration from lower limit sekarang ialah time. Sekarang ni integration of dt. So kita refer kepada time lah. Time punya lower limit is 10. So you put in 10 here, bukan 0. Okay, integration from 10 until t. Upper limit tak perlu isi because we just need to put in the parameter saja ataupun the variable. Variable kita sekarang ialah t. So you key in from 10 to t. Okay, so now kita ada the equation is a equals to 2.4. So you put in 2.4 dt lah. Remember kita replace yang ni, a ni. The value of a kita substitute dengan apa value a. So pada fasa kedua, a is equal to 2.4. So you put in 2.4 here, 2.4 dt. Okay. Now, on this side, bila you integrate dv, you akan dapat v. And then you substitute upper limit minus lower limit, which is v minus dengan 20 lah. Upper limit v minus the lower limit 20. Okay, so you dapat v minus 20 on the left hand side. On the right hand side, integrate 2.4. Kita dapat apa? Anyone? Integrate 2.4. What do you get?
2.4t.
Correct. 2.4t. So, on the right hand side, you akan dapat 2.4t and then you akan substitute upper limit dengan lower limit. So 2.4t substitute upper limit, you dapat 2.4t minus substitute pula lower limit 2.4t multiply with 10. So you akan dapat 2.4t minus 24. Okay, jangan lupa sebelah sini ada lagi ni minus 20. So you kena bawa yang minus 20 tu pergi ke sebelah kanan to get what is the value of v, what is the equation of v for second phase ataupun fasa kedua. So you will get v is equal to 2.4t minus 4, sebab you bawa minus 20 ni datang ke sini jadi plus 20. So minus 24 plus 20 jadi minus 4. Okay, ini you punya equation. So macam mana rupa equation ni? Anyone? Ini equation apa ni? Linear. Tadi quadratic equation. Now we have a linear equation. So you can expect a straight line lah. Linear equation ni maksud dia straight line. Okay, so pada pada t equals to 10, kita dah tahu dah v dia ialah 20. So sekarang ni kita gantikan what is the value of v pada t equals to 20. So you substitute 20 in here, you will get 44. 20 multiply with 24 ni dapat berapa? 48 lah. 48. Okay, you dapat 48 minus dengan 4, you dapat 44. Okay, so this is simply a linear graph. So you just draw a straight line lah. A straight line from 20 to 44. Okay, selesai fasa kedua. Any questions so far?
No.
No question. Orang lain? Ada yang ada soalan? Ada yang ada soalan? Okay, boleh faham Okay. No, okay, good. Now, let's continue to the third phase ataupun fasa yang terakhir, which is 20 to 30. Okay. Now, fasa yang terakhir, t equals to 20 seconds until 30 seconds. Okay. Sekarang ni kita guna yang sama daripada tadi, daripada a dv dt. We have integration of dv equals to integration of a dt. Okay. Remember dekat sini, on the left side, you integrate dv, bukan time. So, kita perlu dapatkan lower limit velocity. Berapa velocity apabila t equals to 20? Tadi kita dah kira dah dekat sini. When t equals to 20, you punya velocity is 44. That's why kita punya lower limit ialah 44. So, integrate daripada lower limit 44 until v. Upper limit kita v lah, the variable. And then here, okay, ni saya lupa tulis kot. This should be from 20 until t lah. This should start from 20. Integration of 0 dt. From 20 until t. Okay. On the right hand side, you integrate 0 is equal to 0 lah. Tak ada apa-apa lah, dapat 0 kat sini. On the right side. On the left hand side, you akan dapat v minus 44. Okay, you integrate dv, you akan dapat v. Substitute the upper limit v minus substitute the lower limit 44. So, dapat v minus 44 equals to 0. Okay, sekarang kita rearrange sikit. Kita akan dapat untuk fasa yang terakhir, v is equal to 44 meter per second. Alright, macam mana kita nak lukis dalam graf? Macam mana kita nak lukis dalam graf v equals to 44 meter per second? It is just simply a straight line lah. Okay, a straight line. So, you akan dapat satu straight line v equals to 44 from 20 seconds until 30 seconds. Okay. So, dekat sini you boleh nampak comparison lah. Tadi kita dah draw AT graph and then kita draw VT graph. So, pada fasa terakhir ni, acceleration equals to 0, bermakna kita dah tahu dah mesti velocity dia constant. So dalam VT graph you nampak betul velocity dia constant lah, 44 meter per second constant. Daripada saat 20 ke 30 saat dia punya velocity sama saja, 44. Okay, so this is what we call erratic motion. Maksudnya pergerakan dia tak sama, sekejap dia memecut, sekejap dia perlahan, sekejap dia maintain velocity and so on. Ada soalan so far? Do you have any question?
So, record aja.
Saya record.
Right.
Nanti saya akan upload dalam YouTube and then I will share in the Google Classroom as well as dalam WhatsApp group lah. Ada soalan? Okay, good. Kalau tak ada soalan, let's continue. We have one more graph to draw, which is the displacement time graph. Okay, kalau you tengok tadi, kita dah lukis AT graph, acceleration lawan time. Kita dah lukis velocity lawan time. Now kita nak draw displacement S lawan time. Yang ni kita belum lukis lagi. Okay, so let's look at displacement time graph. Kita akan guna equation V equals to ds dt. Kalau kita tengok tadi, kita guna A equals to dv dt. This is one of the basic kinematic equation. Ada satu lagi basic kinematic equation. Kalau you ingat dalam tadi mana? In here, okay. We have A equals to dv dt. Yang ni kita dah guna. Now we would like to use V equals to ds dt. Sebab kita nak dapatkan S pula. Kita nak dapatkan function of S. Tadi kita ada A yang diberi kepada kita is the acceleration. We have derived the velocity punya function. Now once we have the velocity punya function, then we can derive the displacement punya function. Okay. Now let me go back to the slide tadi. Here. Okay. Alright. Sekarang kita pergi kepada fasa yang pertama dulu. Fasa 1 which is T from 0 until 10 seconds. Kita ada equation tadi A equals to 0.4 T, and then from this equation we have derived the function of velocity which is V equals to 0.2 T square. Okay. Now let's derive the function untuk displacement S. Kita nak tahu S dia sama dengan apa pada fasa yang pertama ni. Okay. So kita guna V equals to ds over dt. Okay. Then kita rearrange, kita akan dapat ds equals to v dt, and then to get the function of S, kita akan integrate both sides. Okay, kita integrate ds, kita integrate v dt. Okay, remember on this side, ini integration with respect to displacement S. Yang ni integration with respect to time t, dia tak sama. Okay, so untuk saya zoom sikit. Zoom in here. Okay. Untuk this one is integration displacement. Kita mula dengan 0 because we know the object starts from rest, from daripada tidak bergerak. So pada awalnya the displacement is also 0 lah. So from 0 to S, the variable of the displacement ds is equal to time pun sama. Kita sekarang ni lower limit kita ialah 0. So we start the time integration from 0 until t, and what do we integrate here is the velocity punya function, not the acceleration. Kita integrate v dt. ds is equal to v dt. So kita integrate sekarang ni ialah this function 0.2 t square dt. Okay. So what do we have? We have S is equal to 0.2 T to the power of 3 divided by 3. Okay, S ni S tolak kosong lah. Saya dah buang kosong tu. On the left hand side, you should get s minus 0. On the right hand side, you should get 0.2 t to the power of 3 divided by 3 minus 0 juga. So kita buang minus 0 tu. This is what you get. The first equation ataupun function of s pada fasa yang pertama is s is equal to 0.0667 t to the power of 3. Ini function yang pertama. Okay. Macam mana dapat 0.0667 ni? Saya bahagikan ni lah. 0.2 bahagi dengan 3. You will get this number. Okay. Saya continue. Ataupun ada soalan? Ada apa-apa soalan? Kalau tak ada, saya akan teruskan.
No question, sir.
No question. Okay. Suara saya dengar jelas?
Yes, sir.
Okay, good. Okay, sekarang saya akan continue with the second phase ataupun fasa yang kedua. Kita lukis graf kemudian nanti. Kita habiskan dulu, kita terbitkan function S ni dulu. Okay. So, sekarang daripada time T, 10, T equals to 10 until 20 seconds. So, tadi kita dah ada a function of A equals to 2.4 pada masa ini, pada fasa ini. And then we have the velocity V is equal to 2.4 T minus 4. Ini yang kita ada. Now, let's use this equation again. Okay. And now, notice, saya zoom in. Okay. Now, notice the lower limit sekarang ni. Mana you dapat lower limit 66.7 ini ialah dengan kita gantikan dalam ini. Pada T equals to 10, okay, you akan dapat 10 to the power of 3. Okay, you akan dapat S equals to 10 to the power of 3 multiply with 0.0667, okay, times 10 to the power of 3, you will get 66.7. Okay, dekat sini. So, itu datangnya 66.7 lower limit ni. Okay. Okay, 66.7 lower limit tu datang daripada sinilah kita gantikan T ni kepada 10, which is the lower limit untuk fasa ini. Okay. Remember sorry. Remember the left hand side punya, oh ni pun saya ada typing, ada error sikit ni. Ni sama dengan bukan minus ni. Ni sama dengan. So 66.7 is the lower limit for ds. Sebab ini kita integrate with respect to the displacement ds, bukan time. On the right hand side baru kita integrate with respect to time dt. So di sini lower limit dia sama dengan time punya lower limit lah, 10 dekat sini. So that's why you have 10 until t pada on the right hand side. Okay. So left hand side, apa yang you dapat on the left hand side? Anyone? On the left hand side. Correct. On the left hand side, you dapat S minus 66.7. Okay. Integrate yang ni, ds, you akan dapat S. And then you substitute the upper limit, S, minus substitute lower limit 66.7. So you dapat S minus 66.7 equal to, kat sini equal lah, ni salah ni, equal to 2.4t, you akan dapat 2.4t square bahagi 2. Okay, 2.4t square bahagi 2 minus 4 integrate dapat 4t. Okay, sekarang you substitute, saya zoom in sikit. Okay, sekarang you substitute ini, substitute t, you akan dapat inilah, dapat 2.4t square divided by 2 minus 4t. Substitute pula 10 dalam ni. So, you akan dapat 2.4 kali 10 square, 100 bahagi 2 minus 4 times 10. So, you akan dapat minus, you akan dapat 80. So, yang ini saya dah gabungkan. Saya dah masukkan t dan 10 ini, gantikan dalam ni. So, ini yang saya dapat. 2.4 t square divided by 2 minus 40 minus 80. Ada soalan tak yang ni? Ada siapa-siapa yang tak faham macam mana dapat ni? Ada tak soalan? Ke semua clear? Okay. So, kalau ada soalan, just interrupt me and then you can straight away ask the question. Sekarang saya continue saja. So, now when you rearrange this equation, you akan dapat S is equal to 1.2 T square. Yang ni saya dah bahagikan lah. 2.4 bahagi dengan 2 ni, you akan dapat 1.2 T square minus 40. Sekarang ni minus 80, kita bawa 66.7 to the right hand side. So, minus 80 plus 66.7, you akan dapat 13.3, minus 13.3. So, ini function S pada fasa yang kedua. Okay. For the time T equals to 10 until T equals to 20, ini function dia. Okay. Okay, now let's continue to the last phase, fasa yang terakhir. From T equals to 20 until T equals to 30, tadi kita ada A equals to 0, V equals to 44 meter per second. Now, let's integrate again. Okay. Saya zoom in kat sini. Macam mana kita dapat lower limit S is 386.7 ialah dengan gantikan T equals to 20, lower limit untuk fasa ini dalam equation ini, dalam function yang ni. So, you will get 1.2 times 20 square minus 4 times 20 minus 13.3. You akan dapat S is equal to 386.7. This is the lower limit of this integration. Okay, until integrate sampai upper limit dia S lah, the variable. Okay. For the right hand side, you integrate, lower limit is 20 lah, because this one is with respect to time. So time kita lower limit is 20. So from 20 to T, you punya integration, you akan dapat S minus 386.7, yang ni daripada left hand side, and then 44T akan dapat 44 integrate akan dapat 44T, then you substitute T dapat 44T, minus you substitute 20 dalam ni, you akan dapat minus 880. Okay, this is the right hand side punya equation that you have. So bila kita rearrange, finally the function for phase 3 untuk S ialah S is equal to 44T minus 493.3. Okay. So now you have all three functions untuk displacement, untuk S. Inilah kita panggil piecewise function, sebab function dia berbeza mengikut masa. So this is what you call as piecewise function lah. Itu terma mathematical punya terma matematik. Okay. Sekarang kita nak cuba plot. Okay, kita ada on y-axis is the displacement S. Okay, saya dah sediakan axis kita daripada 200 until 800 because we have a large number here. Okay. And then dekat bawah ni samalah, for the x-axis is the same like acceleration and velocity. You have time from 0 until 30 seconds. Okay. Sekarang, you maybe not sure macam mana rupa graf T cube ni, T to the power of 3. Okay, so macam tadi, kita boleh go back to Google, and then kita boleh type in now y is equal to, let's say, 0.0667. Dekat sini saya dah tulis dah, times x to the power of 3. Okay, kita always gantikan y dan x lah, sebab Google dia pandai baca y dan x je. Kalau you letak variable lain, s dan t dia tak boleh recognize. Okay, so when you tick this, okay, this will be the graph. You nampak ini graph untuk x ataupun 0.0667 x to the power of 3. So sekarang kita interested daripada 0 hingga 10. So graf dia lebih kurang macam ni lah. Dia masih lagi curve graph macam ni. So you expect graph dia curve macam ni lah sehinggalah ke 10. Okay. Now let's go back here. So kita macam biasa, we have the range from 0 until 10. So kita untuk time equals to 0, if you substitute, you akan dapat 0. So starting point ia masih lagi 0, 0. What about at 10? So you substitute t to the power of 3, you substitute 10 ini dalam t dekat sini, so it will be 10 to the power of 3 multiply with 0.0667. So sekarang ni you akan dapat, let me zoom in here, you akan dapat 66.7 untuk pada time t equals to 10, the displacement S ialah 66.7. So saya cuba juga calculate what is the value when t equals to 5. So saya dapat 8.34. So graph dia tadi kan kita dah tahu dia curve. So you can estimate graph dia nampak macam ni lah, sedikit curvy daripada 0, pergi kepada 5, 8.34, and then in the end is 10, 66.7. So this will be the graph. Okay. For the next part, fasa yang kedua daripada 10 ke 20. So it's 1.2 t square minus 4t minus 13.3. So now you know definitely this is a quadratic equation. So dia pun akan jadi a curvy punya graph lah. Dia akan jadi satu curve. Okay. So as usual, you will key in the value 20 time t is equal to 20 in the equation here to get what is the value. So you akan dapat value is, let me zoom in again. You akan dapat value when t equals to 20, the displacement S is 387. Okay, yang ni kita dah tahu tadi. Kita dah calculate awal tadi. You can check juga pada time t equals to 15, the displacement is 197. So dekat sini, the second phase is another curve, curvy line. So you start daripada this point, you akan draw a curve up until 387. Okay. Any question? Okay, let's just clear. Okay, let's continue kepada fasa yang terakhir, the last phase. S is 44t minus 493.3. This is clearly a linear graph lah. This is a straight line linear graph. So what you have to do is just substitute value 30 dalam ni to get 826. Okay, 826 dia punya value yang terakhir. So you can then just draw a straight line from 387 straight to 826. So this will be the displacement versus time graph for this particular problem. Okay, so when you put in together side by side, you akan nampak, oh, this is the acceleration pattern. Daripada graph ni, you akan nampak pattern lah. You nampak, oh, this is the acceleration pattern. Mula-mula dia accelerate, and then mula-mula dia increase acceleration, linear increase in acceleration, and then dia maintain accelerate at 2.4, and then habis, tak ada acceleration. For the velocity, you nampak dia quadratic dulu, and then dia akan ada linear velocity increase, and then dia maintain velocity. For displacement pula macam ni. Okay, dia mula-mula dia the equation is the t to the power of 3, t cube, and then dia ada quadratic punya equation pula, t to the power of 2, and then finally it is a straight line. Okay, so daripada sini kita dapat tahu total displacement lah of this particle, of this object, is 826. After t equals to 30 seconds, you dapat S is equal to 826. Okay. Do you have any question? So far, do you have any question?
Enggak ada.
Enggak ada. No question, Okay. Kalau tak ada soalan, I have satu lagi example yang saya nak tunjuk kepada you. And then after that will be the end of the class lah. So macam saya cakap, saya tak plan untuk buat kelas ni selama full 2 jam because it will not be effective. So we will try to finish the class dalam sejam setengah ataupun sejam lebih-lebih sikit, sejam 15 minutes, something like that. Okay. Let's look at example number 2. Okay, saya zoom sikit kat sini. Alright, the sports car travels along a straight road such that its acceleration is described by the graph. Okay, sekarang ni apa yang beza antara soalan yang sebelum ni dan soalan sekarang? What can you see from the graph? Anyone? Apa beza dengan yang sebelum ni? What is the difference?
Dia guna displacement.
Yes, correct. Dia tadi kita plot graph acceleration lawan time. Sekarang ni graph dia acceleration lawan displacement, bukan lagi acceleration lawan time. Okay, so soalan dia ialah construct the velocity displacement graph. Okay, sekarang ni dia dah tak kira time dah. Dia nak tengok velocity dan displacement. So dia nak tahu as the car travels, as the displacement increase, macam mana pattern velocity. So construct the VS graph for the same interval and specify the velocity of the car when S equals to 10 meter and S equals to 15 meter. So dia nak tahu in the end, bila displacement 10 meter, what is the velocity at that moment, and then when S is 15 meter, what is the velocity at that moment as well. Okay. For this particular question, we will use the third basic kinematic equation. Okay, sebelum ni kita guna A equals to dv dt, and then kita guna V equals to ds dt. Now we would like to use A ds equals to V dv. Okay. Let's look at the first part of the motion. The first part is from 0 until 10. Okay, from 0 until 10. You nampak tak? Dia is a linear. Nampak dia punya shape ni betul-betul square. So pada displacement 5 meter, acceleration pun 5 meter per second square. Pada displacement 10 meter, acceleration is 10 meter per second square. So what does it tell us is during this moment ataupun during this phase, fasa yang pertama ini 0 to 10 meter, A is equal to S. Sama. Whatever the displacement is, that is the value of acceleration. So A is equal to S. Yang ni kita, macam mana kita dapat ni? Based on kita punya observation lah, daripada pemerhatian kita kepada graph ni, we can generate this equation. A equals to S pada fasa yang pertama. Okay. Dan kita, what do we want here is the velocity. So daripada sini, untuk dapatkan velocity, kita kena integrate lah. Kita kena integrate ni supaya kita dapat eliminate dv. Kita nak buang dv ni. Bila kita integrate the right hand side, kita kena integrate juga the left hand side. Okay, kita integrate left hand side. It should be A ds, tapi kenapa jadi S kat sini? Because kita dah establish di atas ini, we have established that A is equal to S. Jadi kita terus ganti dalam ni sebagai S. So integrate daripada kosong. Lower limit untuk yang pertama is 0 lah. Lower limit for displacement 0 to S, S ds. Equal to integrate 0 to V, V dv. Okay. Apa yang kita dapat dekat sini? Integrate S ds. Anyone? Kita akan dapat, basically kita akan dapat S, kita akan dapat S equals to V because it is the same left and right hand side. Okay, so in the end bila you substitute everything, you akan dapat for the first equation, for the first phase, S is equal to V. Okay, so this is the function yang pertama, ataupun kita tulis, kita terbalikkanlah because we want VS graph kan. So V equals to S pada fasa yang pertama. Okay. And then kita boleh find what is the velocity. Remember dia tanya what is the velocity pada S equals to 10 meters. So we can, when we have this relationship, this function, we substitute S equals to 10 meter. So kita dapat V pun ialah 10 meter per second juga pada fasa yang pertama. Okay, now let's go to the second phase, which is from T equals to 10 until T equals to 15. Okay, daripada sini, daripada graph ni, from the observation, you will know that A is equal to 10 pada keadaan ini. Nampak tak? Tadi kita kata A is equal to S kan? Dia sama sahaja. S5, A5. S10, A10. Pada fasa yang kedua ni, A dia constant pada value 10. So that's why we write A is equal to 10 pada fasa yang kedua. Okay, pada fasa yang kedua, from 10 meter, S is equal to 10 meter until 15 meter, A is equal to 10. Okay, then kita repeat again the same process. Now we have integration of V dV equals to integration of 10 ds. 10 ni datang dari mana? Datang daripada sinilah. Kita dah substitute A ni sama dengan 10. Okay, sepatutnya integrate of A ds, tapi kita dah tahu value A is equal to 10, so kita put in here 10. V here is the lower limit when S is equal to 10. Dekat sinilah, this is why we calculate what is the value of velocity pada displacement equals to 10, we get velocity 10. So you have from 10 until V dV, and then you have from 10 displacement 10, okay, dekat sini, until S 10 ds. Okay, so dekat sini you akan dapat V square over 2, and then gantikanlah V square over 2 ni, ganti dengan V, you dapat V square over 2, and then ganti pula dengan 10, so dapat 10 square over 2, 100 bahagi 2 dapat 50. So this is on the left hand side. On the right hand side, you akan dapat 10s dekat sini. So dapatlah 10s minus, gantikan lower limit, S ni ganti dengan 10, so 10 kali 10 you dapat 100. Okay, so buat sedikit rearrange, you akan dapat V is equal to 20s minus 100 square root. Okay, this is the equation yang you ada. Okay, now before we draw the graph, you may be tak sure macam mana rupa graph yang square root ni. Okay, so let's go back to Google tadi. Kita boleh write, kita boleh search Y is equal to put in the bracket 20x minus 100 tutup bracket to the power of, square root is to the power of half, 0.5 to the power of 0.5. So this is what you should write. Y is equal to 20x minus 100 dalam kurungan besar in bracket to the power of 0.5. When you press enter, okay, so you know that the graph should look something like this lah. This is the graph of x to the power of ataupun square root of x. Okay, x to the power of 0.5. So yang kita nak sekarang is from the value of 10 until 15. Okay, 10 until 15 ni dekat sini lah. Lebih kurang 10 here until 15 kat sini. So basically kalau kita zoom in, okay, kalau kita zoom in 10 dekat sini, 15 ni dekat sini, dia almost macam straight line juga. Okay, saya zoom in lagi. 10 until 15 ni nampak? 10 until 15 ni dia macam, walaupun dia sebenarnya curve, tapi dia macam straight line lagi lah. Untuk ni 10 until 15, dia macam curve ke atas gitu sikit je. Alright. Sekejap ada soalan tadi dalam chat box, kalau nak cari tahu graf tanpa search macam mana? Saya tak faham soalan, boleh repeat balik soalan tak? Apa maksud soalan awak ni?
Maksudnya macam kita nak cari tahu bentuk graf tu, tapi tanpa search, tanpa macam yang saya buat ni, cari kat Google lah semua.
Tak, kalau saya tunjuk ni bukan you mesti tengok Google. Saya nak bagi tahu kalau you
cara lain
dia tak ada cara lain. Kalau you tahu, kalau you tahu sendiri by heart, maksudnya you ingat graf tu macam mana, tak apalah. Tapi saya tunjuk ni kalau in case you tak sure macam mana graf x kuasa 3, macam mana graf square root x. Kalau you tak pasti, you can use Google lah. Itu maksud saya. Tak semestinya you guna Google ni. Tak nak guna pun tak apa. Okay. Alright. So let's go back to this. Okay. Untuk fasa pertama, kita tengok fasa pertama dulu daripada 0 hingga 10. 0 to 10, kita ada V equals to S. So ini clear lah. Ini clear. We have a straight line. Sama macam acceleration tadi. S equal to 5, V equals to 5. S equal to 10, V equals to 10. Okay. Settle. Untuk fasa kedua, okay, what I did was, saya cuba cari what is the value when S equals to 15. Okay, so saya gantikan lah S 15 dalam ni. So 20 kali 15 tolak 100 square root. Saya zoom in kat sini, saya dapat 14.1, 14.1. Okay, saya dapat 14.1. So yang before that, yang lower limit tu kita tahulah, lower limit tu is 10 lah bila kita gantikan. Okay, so tadi dalam Google tadi pun kita dah tahu dia macam almost straight line je daripada 10 ke 15 ni. So that is why I just draw a straight line lah, almost straight line. Sebenarnya dia ada curve sikit lah, dia curve ke atas sikit. Okay, so that's it. So settle lah kita punya velocity lawan displacement graph. So VS graph settle. So at S equals to 10, kita ada V equals to 10 meter per second. And then soalan lagi satu dia tanya, at S equals to 15, we know V is equal to 14.1 meter per second. Okay? Ada apa-apa soalan tak? Ada apa-apa soalan? Jelas? Jelas eh? Okay. Tak apa, kalau you ada apa-apa yang you tak dapat tangkap, you can always tengok balik video ini. Saya akan upload di YouTube later. And then saya macam biasa, saya akan buatkan chapter-chapter dalam YouTube tu. So mudah untuk you tengok ataupun refer bahagian mana yang you nak tengok. Okay. So to summarize what we have discussed today, we have learned about erratic motion. Okay, remember dalam motion ini kita dah belajar so far continuous motion. Maksud dia motion tu sama je daripada awal sampai habis, dia sama. And then today we have discussed about erratic motion. Maksudnya motion dia tak sama. Daripada time 0 to 10 motion dia lain. Daripada 10 to 15 motion dia lain. Daripada 15 until 20 for example motion dia lain. So because of this difference, it cannot be described by a single mathematical function. Tak boleh ada satu je. So this is why we derive piecewise function. Piecewise function ni tadilah A, lepas tu dia ada bracket, lepas tu dia ada A equals to apa untuk time sekian-sekian. A equals to apa untuk time sekian-sekian. So that is called piecewise function. So kita dah derive piecewise function of velocity and displacement from the given acceleration punya piecewise function, the example number 1. And then kita dah learn how to plot the graph of displacement lawan time, velocity lawan time, and also acceleration lawan time. And then the last example number 2, we have also discussed ataupun we have also plotted the graph of velocity lawan displacement. Tadi lawan time, sekarang lawan displacement S, and also the acceleration versus displacement. Okay, so that is what we have covered today. So kita dah pun 1 jam kelas ini. It's now about 3:10. So I think that is all what I would like to deliver to you today. Do you have any question? Ada apa-apa soalan?
Yes, sir.
Okay. So kalau tak ada apa-apa soalan, saya belum ready lagi dengan soalan. I would like to give you some assignment lah yang you boleh buat di rumah. I will give you the problem in the Google Classroom so that you will try to do this at home, derive the piecewise function macam kita buat tadi, and then draw the graph macam yang kita buat tadi lah. So I will give the question later, maybe tomorrow in the Google Classroom. So I want you to do and then maybe in the next class, kalau you sempat siap, kita akan discuss, ataupun we will discuss ataupun I will ask you to submit lah in the Google Classroom later. Okay, is that okay? Boleh boleh. Okay. Alright, so later let me prepare the question first, and then saya akan bagi dalam Google Classroom. Maybe I will do a few questions, so bukan semua orang akan dapat soalan yang sama lah. Maybe you will get a different question from your friends. So I hope that you can do it yourself to get yourself familiar with how to derive the piecewise function as well as macam mana nak draw the graph lah. Okay, so kalau tak ada apa-apa soalan, that will be the end of the class for today. As usual, I will upload the video in YouTube. Before we end, let me snap the picture jap for attendance. Okay, so that's all for today's class. Again, thank you for attending the Google Meet session, and I hope that I have delivered the material on erratic motion ini, and you have understood what we have discussed in the class today. And I will see you again on Wednesday, the same time, 2 p.m. Wednesday. Okay. Alright, so thank you everybody, and see you again on Wednesday. Assalamualaikum and a very good day.
Thank you, sir.
Thank you, sir.